are basically three types of power wheelchairs: front-wheel drive, mid-wheel drive, and rear-wheel drive. And every platform comes with its advantages, but also with its disadvantages. So it is actually very important to know for you, for your customer also, what to expect when advising a certain platform. Today, we're going to guide you through all those benefits, but also through the disadvantages and challenges, and sometimes also how they can be solved. The learning objectives for today is that we will help you to recognize and distinguish the three types of power wheelchair platforms, like already mentioned: front wheel, mid wheel, and rear wheel drive. We'll also help you to learn about the decision criteria that you can use to select the right platform for your customer. And last but not least, we'll also help you to identify the benefits of every platform. Some rules for internal housekeeping of the webinar. So at the start of the webinar, all the participants will be muted, and you can ask your question via the chat function. The presentation here, it mentions, will be 45 minutes, but that's actually very largely counted. I estimate it somewhere between 30 and 45 minutes. And then the last time available, we can actually use it for answering all your questions that came in, or for the additional questions that can come in through the chat function. Tomorrow, on Friday, we will send out a handout version of the presentation, but also the link to the recorded webinar for the ones of you that cannot attend the full webinar, or the ones who could not attend the live session, so they can review it at their most convenient time. So let's get started with a very short introduction. There's actually a very strong historical perspective in those three platforms that I already have mentioned. So it's basically after the Second World War, and when that war ended in 1945, a lot of individuals, soldiers, but also civilians, were injured during the war and had high demands for independent mobility. So far, actually, there were only manual wheelchairs. And in the picture at the left, you see actually two engineers sitting next to an Everest and Jennings wheelchair, trying to figure out how to build it into a power wheelchair. It actually, since that the technology wasn't largely available, it took until 1955 until the first mass-produced power wheelchair was available, and that one was fully based on an existing manual wheelchair. Now, the manual wheelchairs mostly have the propelling wheels, or the big wheels, in the rear end of the wheelchair. So it was basically very convenient at that time to have a rear-wheel driven platform. In the 60s, we had a stubborn Swedish doctor called Permobil, and Permobil is actually the founder of Permobil. That he was a doctor in Sweden in a rehab unit, and he ordered one of the first power wheelchairs for one of his patients. But soon he also noticed that that power wheelchair had its limitations, especially when you wanted to drive it outdoors. So as a stubborn person as he was, he started to try to modify that wheelchair, but in the later stage, he actually started to prototype the first front-wheel driven platform. And it took until 65 until he had a real prototype that was usable. And actually in 1967, the company Permobil was founded, and then the mass production of front-wheel driven platforms also took place. You have to understand, until the 80s, power wheelchairs were quite difficult devices to use. They were not as convenient and not as easy as to operate as they are now today. But in the early 80s, and that was also thanks to the game industry, probably some of you recall the Atari computers and so on, those game computers had a device that was very convenient, and it was called the joystick. The joystick had a microprocessor that actually facilitated also controlling a wheelchair, and that microprocessor actually pushed for an increased user access. Now, in economics or in corporate life, when there's an increased users access, there's also increased opportunities. And it's from then that we see that quite a lot of companies were established and started developing also power wheelchairs. Then it took until actually the late 80s to see that first mid-wheel drive platforms emerged. And the first mid-wheel drive platforms were actually power wheelchairs that were intended to use indoors. They were extremely compact, had a very short turning radius. So those were very convenient devices to use indoors. But at the same time, most of us know that customers who need a power wheelchair indoors very likely need also that power wheelchair outdoors, and they don't want to transfer from the one wheelchair to the other one when they want to go out. So we see actually in the early 2000s, even in early 2010s, that mid-wheel drive platforms actually started to improve. The functional performance outdoors improved significantly, and the mid-wheel drive platforms start to take over the markets. And now, we're being in 2020, we see that in the most of the markets, mid-wheel drive is now the dominating platform and the most frequently sold platform. So we actually have to acknowledge that this type of platforms have conquered the market, and that is only because the functionality and the functional performance of those devices have significantly improved. So when you're looking for a wheelchair for your customer, it's basically you need to basically connect your customer with a power wheelchair, with this assistive device. And the main objective is that you need to select a wheelchair for your customer that best allows to carry out their daily activities. Basically, what users want to do with a power wheelchair is to achieve a higher functional level. So it is extremely important to find a good match between the product and your user. And that's for specific reasons and several reasons. The first one is that we know that if you have the right product for your customer, we see, or you can see, an increase of successful participation. And participation actually occurs in several levels. It can, you have professional participation or educational participation, but also social participation, to participate in social life or in the family life. When we see an increase in participation, we know also that participation has a direct correlation with health-related quality of life. So when you see an increase in participation, you can actually also expect an increase in the quality of life for that use, the health-related quality of life. And a third reason is that by selecting the right device for your customer, you can also avoid substantial financial costs related to wheelchair abandonment. And in this case, actually, I don't really care who has paid for the device, whether it's now with a reimbursement or if it's private funded. But this devices come with a certain cost, and you should, of all times, avoid those substantial costs when you're not having the right combination between your customer and the device. So wheelchair abandonment is basically a terminology that we use when users stop using their wheelchair because basically the wheelchair is not covering their needs. So of all times, we should actually avoid this situation. And then the importance of a good match, and that is I mentioned also the reference of the literature below, but something very, let's say, curious to read is that individuals with a disability, they actually don't perceive their disability as their most limiting factor. They don't perceive their environment as the most limiting factor. They do perceive the wheelchair as the most limiting factor in their life. So it's basically the wheelchair that prevents them from going into a restaurant to have dinner with friends. It's the wheelchair preventing them from going to work or execute educational activities. So this wheelchair, again, should basically solve their mobility questions and bring a solution to enable participation at all levels. So again, this is why it is so important to have a good match between the assistive device and the user. And there's basically several ways to categorize power wheelchairs. And the most common way that we also see in the most markets is that they are categorized into indoor, indoor/outdoor, and outdoor wheelchairs. Now, I have to say, Permobil doesn't, as a company, doesn't really have those typical indoor wheelchairs in the portfolio. We have obviously wheelchairs that can be used indoors, but those indoor wheelchairs, like there is displayed at the right hand side, we don't have these in the portfolio. But I do want to cover this topic just to give you a complete overview. So the intended use obviously is primarily indoors. And the characteristics of this type of device is that they have a very small footprint and also a very small turning radius. They mostly have also a very slow speed, but let's say fast enough to use indoors. The battery range, obviously, when you only use it indoors, you don't need to have a battery range of 35 kilometers. So the battery range is mostly limited, making or enabling also this compact design. They mostly have smaller drive wheels, and due to this, they also have low obstacle climbing capabilities. So it's basically quite difficult to conquer a threshold with this type of device. There are mostly no power seat functions or available, or when there are available, it's mostly limited to one. And the seating unit mostly has no or limited adjustment possibilities. This type of device doesn't really allow for alternative drive controls, but very likely if you have a type of user that can actually sit without power seat functions, you can also estimate that they won't need an alternative drive control at that time. And this device has little to no suspension. Normally indoors, we normally have a very smooth surface, so you don't need a suspension system on this type of device. The second group is, as I mentioned already, is the indoor/outdoor power wheelchair. The characteristics of this type of device is that they have a mid-size footprint, and they actually have a very acceptable turning radius. The turning radius of these devices are sufficient to actually operate it indoors. Mostly they have faster driving speed, and they have a high battery range. They also have larger drive wheels, and they frequently have mostly they have a suspension, but very frequently now it is designed even as a independent suspension system. The obstacle climbing capabilities is mostly up to 7.5 centimeters, or for our fellows in the UK, 3 inches. And in this type of device, all the power seat functions are available. So what are all the power seat functions? Basically, it is tilt, recline, power leg rest, elevation, anterior tilt, and standing. The seating unit of this type of device comes with a large amount of adjustment possibilities, or it also allows custom seating. For example, if your customer needs aftermarket backrest, or if he needs seating orthosis or custom molded seating, you have the possibility to mount these type of seating on the indoor-outdoor platform. Very frequently, the ESP or gyro technology is also available, and I will come back to this. And there's also a possibility to include alternative drive control options. And then the last platform is the outdoor wheelchair. The intended use, obviously, again, primarily outdoors. And the characteristics of these type of wheelchairs is that they have a rather large footprint. But there's a very specific reason for this, because they have mostly very large batteries for quite a decent driving range, but also they have a larger footprint to ensure stability when you're going over-road. As a result of this large footprint, these devices have mostly a large turning radius. And at the bottom, you see also that I have mentioned that they frequently have a power steering with a servo motor, and that actually can cause also the turning radius to become quite large. This type of devices have a very high driving speed, and as I already mentioned, they also have a high battery range. They have large drive wheels that helps you with obstacle climbing, and we can say that the obstacle climbing capabilities of these type of devices are at least 7.5 centimeters, so very likely they can do more. There's a very good suspension system, and mostly we see also that there's a limited amount of power seat functions only available. Mostly you have a tilt, a recline, or a power leg rest, but for example, standing functions are not mostly not available on this type of device. Mostly, this device is also equipped with a seating unit with adjustment possibilities. So these are now 3 categories. And basically in these 3 categories, we always see the 3 drive platforms returning. We always see in these categories mid-wheel drive wheelchairs, we see front-wheel drive wheelchairs, and we see rear-wheel drive wheelchairs. So I have organized a poll to know your personal preference. So I'll start a poll right now, and let's see in the ones attending what your personal preference is. So the poll is now open, so please click on your personal preference just to know, and I know that most of you are therapists or assistive technology professionals, so I really want to know what your personal preference is for the drive platforms. And I see the most of the results are actually coming in. More than half of you already voted. I see now that 70% already of you voted, so that's really good. And I think then we will get a very representative image also of the preferences. So let's close the poll now, because I see it's stalling the amount of votes. Let's close the poll in let's say 5 seconds, and no new votes are coming in. So the poll is now closed, and I can say that 27% of you voted for the front wheel drive, 12% voted for the rear wheel drive, and 61% voted for the mid wheel drive. And that is actually confirming what I stated in the beginning in the historical perspective, that the mid-wheel drive has now conquered the market. Actually, the functionality of the mid-wheel drive is actually taking the best of both worlds of the rear-wheel drive and the front-wheel drive. So I'm actually very pleased to see this confirmed now. And I think we can continue with the presentation now, because when you need to select a power platform, you need to define also what your criteria are to help to take that decision. And to help you, we have basically created an overview of 6 criteria that can help you to bring you to the best suited platform for your customer. And the first one is the positioning of the seat. So how is the seat positioned on the base? And things that are very important or that need to be taken in consideration when you're positioning the seat is, for example, caster clearance, or the center of gravity, or what is the minimal knee angle that is possible, or what are the driving capabilities on softer surfaces. The second criterion that can help you, and soon in the following slides, I will go more into detail of those criteria. A second criterion is stability. And stability obviously is extremely important to ensure safety of our, or the safety of our customers. So stability will actually, and it's very closely related to the positioning of the seat, it will basically determine how stable and how easy the chair will tilt when you're driving uphill or downhill, or when you're decelerating or accelerating with the wheelchair. A third criterion is comfort, and obviously comfort is extremely important for every customer. But comfort is also how is the wheelchair or the base actually helping you to filter shocks and vibrations when you're driving outdoors. So I'm not talking about the comfort of the seating unit. I am talking about the comfort of the base. So we'll have a closer look in this section later on in the following slides. The next criterion is the indoor usage. How does the wheelchair behave indoors? How much space do you need to turn? How easy can you actually enter a room through a doorway? What are the targeting capabilities? So that's an important criterion. The next one, as I already mentioned, is also outdoor usage. So how does the wheelchair handles outdoor? How is the tracking at high speeds? What are the obstacle climbing capabilities? And then the last one is the intuitivity. And the intuitivity is basically related to the ease of use of the product. How easy is this platform to operate? Do you need lots of judging skills basically to estimate how your wheelchair, how you need to take a turn? So these are all important criteria to take in consideration. And now in the following slides, I will go deeper into each and every criterion. And the first one that we mentioned was the positioning of the seat. So what is the impact of the positioning of the seat, or how does a certain platform allows the positioning of the seat, and what are the outcomes for the user? Well, first of all, with the positioning of the seat, you will influence the weight distribution and the center or the location of the center of gravity of the user and the wheelchair. So when your center of gravity is located more to the front, in the case, for example, as you see in the picture below, to the front in the rear wheel drive, we see that there's a higher load on the caster wheels because the vertical projection of the center of gravity is closely located to the caster wheels. So how does this affect the maneuverability? How does this affect driving on softer surfaces? If there's a higher load on the caster wheels, we know that maneuverability is decreased. It requires actually much more force and torque from the motors to have the same driving experience. So the maneuverability becomes much more difficult. When you have a high load on the caster wheels, we also know outdoors, when you're driving on softer surfaces, for example, on gravel or in a forest, you will have the tendency to plow the caster wheels into the surface. So this is actually something that needs to be avoided of all time. So center of gravity positioning in a rear wheel driven platform is extremely important to improve the driving capabilities or driving characteristics of the wheelchair. With the mid wheel or the front wheel driven platforms, we see that the vertical projection of the center of gravity is much closer to the drive wheels, meaning that the load on the drive wheel is much higher, ensuring that you not only have a good traction on softer terrain, but it ensures also that the casters aren't overloading, and it assures that you have a good maneuverability. Another thing when positioning the driving unit is that you need to create clearance for your caster wheels. So if we look into the front wheel driven platform, the picture at your right, you see that the leg rest is actually not, or the position of the leg rest is actually not compromised by the pivoting caster wheels, because the caster wheels are mounted in the rear part, in the rear end of the wheelchair. If you look at the left-hand side to the rear wheel driven platform, then you see that you actually need to change the angle of the leg rest to create full clearance for the caster wheels. So this basically doesn't create sufficient capabilities to have a short positioning of the leg rest. You cannot really position the leg rest into 90 degrees, or you need to inhibit the speed, because otherwise the pivoting caster wheels will hit the leg rest. In the mid-wheel driven platform, you see basically that issue has been resolved by adding smaller caster wheels. So in a mid-wheel driven platform, we see the capability of having the leg rest in 90 degrees, and then not actually compromising the pivoting caster wheel. The second criterion is stability. And the stability of the wheelchair, I try to actually mimic a situation with driving uphill and downhill. And again, I worked with the vertical projection of the center of mass, because basically stability is the vertical projection of the center of mass within your base of support. As long as this vertical projection is within your base of support, you're safe. If this vertical projection falls out of your base of support, you will fall with the wheelchair, or the wheelchair will tilt. So to ensure the safety, we actually see that with the rear wheel driven platform, when driving up hills, we see that it is actually compromised, because the vertical projection is already very close to the rear wheel. And in this case, the seat is actually in a full horizontal position, whilst most of the customers are actually seated in a tilted position. So when you tilt your seat and you want to drive up hills, we see that the stability, rearward stability of the wheelchair is compromised. And to prevent users from falling with the wheelchair, we have to add anti-tipper wheels. If you look into the mid-wheel driven platform and the front-wheel driven platform, then you'll see that the stability is not really compromised driving uphill. Those are two very stable platforms. And then driving downhill, basically it's not really an issue for the rear-wheel driven platform and the mid-wheel driven platform, but it can be an issue for the front-wheel driven platform. But fortunately, users can actually compensate for this by using their tilt function if they have a tilt function available. But for security reasons, we will also add anti-tipper wheels to prevent users from falling frontwards with their wheelchairs. Well, you also need to take in consideration that not only power seat functions can actually compromise the stability of a wheelchair or a platform, it can also be done by additional adjustments or customizations. For example, when your customer is using a ventilator on a ventilator tray that is mounted behind the seat, that adds a lot of weight behind the seat, and that can also influence the center of gravity positioning of the wheelchair. So always take this in consideration when selecting drive platforms. The third criterion is comfort. And I already mentioned that when we're talking about comfort in this part, we talk about the comfort of the drive platform and the capabilities of filtering out the shocks and vibrations. So first of all, what you need to consider is the amount of points of contact with the surface. A front-wheel driven platform and a rear-wheel driven platform have only 4 wheels. So it's basically 4 points of contact that can transmit shocks and vibrations through the base to the seat and the user. A mid-wheel driven platform has 6 points of contact. So those are 2 points of contact additionally that can also transfer shocks and vibrations. So it makes it a little bit more challenging to make this type of platform comfortable. Additionally, since your user weight is actually almost located, or the center of gravity is almost located above the drive wheels, it is actually much more challenging to have a very efficient suspension system. And this is not the case for a rear-wheel driven platform and a front-wheel driven platform, because the vertical projection of the center of mass is located between the 4 drive wheels. And with this independent suspension systems, you see that the comfort of these type of devices is very high. Obviously, the wheel diameter can also influence the comfort of a power wheelchair. Mostly you see in a rear-wheel driven platform that the caster wheels are slightly bigger than the other drive platforms, and that is actually also to cope with the plowing in softer surfaces. But the wheel diameter can actually significantly improve the comfort. And then the last item that can influence comfort significantly is the type of tires, whether you are going to use pneumatic tires or solid tires. Solid tires are very frequently chosen because of convenience. You cannot have flat tires. The tire is basically always inflated with the, well, not inflated with the right amount of pressure, but basically there's no underinflation of the tire. Air tires offer lots more comfort for the user. And in the most of the mid-wheel driven platforms, it's actually very challenging to find caster wheels with air tires. But with Permobil, with the Permobil M5, we actually have found a solution to cope with this issue, and we can offer pneumatic tires on a mid-wheel drive, increasing significantly the comfort for the user. The next one, the next criterion that helps you to decide on the platform is the indoor use. How does the chair behave indoors? And there are a few items I want to show, and I really hope that the videos are working this time and that I'm not having technical issues. But when you have actually the turning radius between the different drive platforms can vary significantly. Mid-wheel drive generally requires significantly less space for a 360 turn. So you will see that the mid-wheel drive has also the shortest turning radius. The dimensions that you see displayed here on the slide are the dimensions of our drive platforms. So it's not representative for competitor wheelchairs. You see that the turning radius from a front-wheel driven platform is slightly bigger than the one from a mid-wheel driven platform, but you see with a rear-wheel driven platform, the turning radius becomes quite large. And that's just because of the fact that you need to also position the leg rests in a larger angle to cope with the caster clearance. So that is one of the main reasons why why rear-wheel driven wheelchairs have a larger turning radius. Maneuvering in tight spaces with wheelchairs can always be challenging, but then looking into the different types of drive platforms, we can see that the one platform can be much more challenging than the other one. Pictured below or pictured in the video is a situation where you drive from the hallway into the bathroom. And the first wheelchair that does this is the mid-wheel driven platform. So you'll see that it's basically sufficient to approach until the shoulder level of the customer and then make the turn to enter the bathroom. The second situation is the same situation, but now with a rear-wheel driven platform. And if you do the same as with a mid-wheel driven wheelchair, you see that actually the leg rests will rapidly hit the side of the door. So you actually need to change your trajectory, and hopefully your hallway is also large enough to cope with this situation. So you can have basically, so you can take a large turn to be able to enter the bathroom. The last situation is a situation with the front wheel driven platform. And in this platform, you can actually quite rapidly make the turn into the bathroom. But please notice that the rear end can swing out. So this can also require a slightly larger hallway than you need with a mid-wheel driven platform. Another situation, and this is actually what we call targeting and frontal approach. Another situation is when you're in this bathroom. So you see the sink is located in a corner, and this is basically an everyday situation. Hopefully the bathroom of your customer has, let's say, a much more convenient setup for him. But this is actually real-time situations that we encounter almost also on a daily basis. So when your customer wants to position himself in front of the sink, for example, to brush his teeth, with a front-wheel driven platform, we see that the targeting and the frontal approach is quite efficient. So basically with one movement, he can immediately position him in the best possible way. The second situation is with the mid-wheel drive platform, and there we see that it is actually also the targeting is not as good as with a front-wheel drive. You're slightly off-centered, but the targeting is still very acceptable. So basically with moving once back and forth, your customer can position him also in the most convenient and optimal position. The last situation is a little bit more challenging because this is now with the rear-wheel driven platform, and due to the large turning radius, you can actually not approach close enough to the sink. So this will require driving back and forth a few times before your customer is positioned in an ideal way in front of the sink. The next criterion is outdoor use. So outdoor use is for a lot of customers important, and we have a few subcategories in this criterion. One is obstacle climbing, and obstacle climbing can be done from a standstill. It can also be done from a run-up. Now, you have to imagine that a front-wheel driven platform in this situation is actually in both situations, from a standstill and with a run-up, it's the most convenient platform, because the first wheel hitting the curbstone is actually your drive wheel. So that wheel has power enough to conquer the obstacle. With a mid-wheel and a rear-wheel platform, the caster wheels actually hit the curbstone first. So it's a bit more challenging. Now, this video only shows a front-wheel driven platform and a rear-wheel driven platform, but it shows the differences. And these, I have to mention, this is a video with the credits from the Christopher and Dana Ree Foundation. So in this video now, you see that basically the drive wheels hit the curbstone, and then the caster wheels just follow with the rest of the movement. When you will see now the rear-wheel driven platform with the run-up, you will see that the caster wheels hit the curbstone quite violently, and that makes actually the traction wheels spin. So this is with a run-up. So basically you have a momentum. But when you want to do this from a standstill, this becomes even much more challenging with a rear-wheel driven platform. With a mid-wheel driven platform, the most of those platforms nowadays have actually an integrated mechanism with the swing arms that allows them, when you hit an obstacle with the front caster wheels, the swing arm is lifted, lifting the front casters on top of the curbstone, and then you can continue basically with the drive wheel climbing the obstacle. There's also a behavior at high speed. So if we look into front wheel and rear wheel and mid wheel driven platforms, we see that they have very good behavior and stable. They are stable drive platforms at higher speeds. You also need to judge on the behavior of a drive platform in combination with alternative drive controls. So this is the behavior, basically the tracking behavior of a rear-wheel driven platform at high speeds, and this is the same behavior of a mid-wheel driven platform. If we look into a front-wheel driven platform without a gyro or ESP module, it's actually almost impossible to drive this platform in a decent way at speeds higher than 9 to 10 kilometers an hour. So basically, when you have a power wheelchair front-wheel driven with 12 kilometers an hour, it would be impossible as well to drive with this wheelchair at that speed without an ESP module. Because normally you will have the tendency to oversteer and correct continuously, and making that wheelchair or that platform to fishtail. But fortunately, since 15 to 20 years, actually, there's an ESP module available on the most of the wheelchairs. An ESP module is a gyro module that ensures and help you to keep the tracking or a straight tracking of the wheelchair. It's a device built in the electronics that when you give the command with your joystick to go straight ahead, the motors of your wheelchair will compensate to ensure that you actually also have a straight movement. So in the early days, in front-wheel driven platforms, maximum speeds were not as high as the other platforms just due to the lack of a gyroscope. But now with the technological solution, we can actually also offer those high speeds in front-wheel driven platforms. Another thing I already mentioned is the caster load on soft terrain, but also the high centering. And the high centering will be explained in the two following slides. So I think I already explained the caster load on soft terrain and casters plowing when they are overloaded, like with the rear-wheel driven platform. So maybe it's better now to focus on the high centering. And high centering is actually quite difficult to explain when I can't visualize this. So I can show you first of all this video. So high centering is basically when you are having a mid-wheel driven platform and you enter a ditch. So when you're in a ditch, the front end and the rear end, the front swing arm and the rear swing arm are actually lifted. And when your suspension system is not sufficient, you will lose traction with your power wheelchair. So of all times, this should be avoided. Now, there's actually a strange synergy between stability, comfort, and traction in mid-wheel driven platforms. It is actually very difficult to offer all at the same extent. Mostly when you offer or want to offer a lot of stability in wheelchairs, you see that it actually compromises the comfort and the traction of your wheelchair, or vice versa. If you want to have a very soft suspension to offer a lot of comfort, you will see that your stability will be compromised. Now, and that's the reason why we added also this graph into this section. So what we try to do, or what we see in the most of the power wheelchairs available, is that they work with progressive springs. So the harder the spring is compressed, the more force you need to further compress the spring. And actually this type of spring doesn't really help to prevent the high centering. You can try to go for a linear suspension, but this is extremely difficult to develop. So what Permobil has done basically with the suspension system in our M series is that we work with a degressive spring mechanism. So basically the initial force needed to compress the spring is higher than when you have a certain amount of compression already in the spring. And this really helps actually to ensure that we have a good comfort and that we also have a good traction, but at the same time that we can also offer sufficient stability to the user to be safe, but also to be safe when he's, for example, using his lift function when he's driving the wheelchair. The last decision criterion is the intuitivity. And the intuitivity is actually one of the most important things of the wheelchair for the user. So remember this situation that I have shown with a rear-wheel driven platform that wants to enter a bathroom from the hallway. So this is what I mean basically with judging skills, because you need to take a large turn to prevent this. Or you need also judging skills with the front wheel driven platform to estimate the rear end swinging out. So how do the different platforms now perform in the intuitivity? And actually there's in literature also a statement that it talks about the rotation axis of the wheelchair and the rotation axis of, or let's say the anatomical rotation axis. The closer those two axes are, or the closer the distance between those two axes, the more intuitive the wheelchair becomes. So in a rear-wheel driven platform, the rotation axis is more located to the back than the anatomical axis. And actually you cannot see the mechanical rotation axis of the wheelchair, making it a bit more challenging from an intuitivity level. It also needs, as I already mentioned, more judging skills to determine at what point to begin the turn. In a mid-wheel drive, those two axes are very close to each other. So it is very logical. So you don't need wide turns. You have no rear end swinging out. So it's a very simple platform to learn to drive with. The last one is the front wheel driven platform. And there the rotation axis is in front of the anatomical axis, and it is also quite closely located. So this is also being considered as a highly intuitive platform. But again, you need some judging skills to estimate that the rear end also swings out. So that brings us to the summary, and I see that we are already coming close to 45 minutes of presentation, so apologies for that. In the last 3 slides, I basically gave an overview of the most important characteristics from and the benefits and challenges in the different decision criteria. The first one is here with the front wheel drive, and every time you can basically see a summary. So it is more convenient for you to read in the handout than as for me now to present the same content over again. The second one is the mid-wheel drive, again with the benefits and the challenges. And the last one is the rear-wheel drive platform with the benefits and the challenges. But maybe most important, and this is also what I want to, the slide I want to use to wrap up with, how do you evaluate and how do you make decisions? Well, basically you need to weigh the results, and not all criteria have the same weight in taking the decisions. There are mostly two decision parameters that are generally very important, and you take this decision obviously in consensus with your customer. But the two decision parameters most important for you or for the customer are mostly the indoor usage. Most of the users spend more than 85 to 90% actually indoors. So the maneuverability indoors is super important for them. Evaluate this in the current environment, for example, when you have users who are already experienced users, but also for potential environments. Because some of the users are newly injured and cannot really go back to their domestic situation and need to move. So take this in consideration. The second parameter is the intuitivity and how easy it is actually to operate and steer the platform, how easy it is to learn to drive with a wheelchair. Preference is not necessarily related to the environment or the activities. Preference can actually be based on prior experience. If you have a customer that has been using a rear-wheel driven platform for 20 years, very likely he has built his expertise and he doesn't experience a rear-wheel drive platform as being inconvenient for indoor use. So this is something you also need to respect. It is basically, the results is a complex interaction between the variables, and it makes it difficult also to isolate the influence, basically to isolate the influence of one factor over another. And basically to determine the best platform for your customer and the performance of a particular wheelchair, it is actually only possible by doing it by trial. Have your customer testing wheelchair, have his inputs, have his returns on how the wheelchair behaves and how it actually does it meet his needs. That's the most important consideration you can make. Now let's have a personal invitation first for the next webinar. So maybe you recall the topic we had in June when we were talking about the cherry picking of seating objectives, and this is basically a webinar with content that builds further on this topic. But now we will go more into an evidence-based, or let's say continue the evidence-based approach with test methodologies on how to basically qualify products on their delivery for the seating goals. I will include a invitation tomorrow and a link to register for the next webinar. If it's at your interest, we'll welcome you gladly in the next session. So it's now time to come to the questions of the webinar, and I have the first questions coming in, or the first questions already, so I'll take those ones first. I have somebody asking regarding a reversible platform, and correct me if I'm wrong, a reversible platform is probably one of the platforms that you could see on the market where you could change from rear-wheel drive to front-wheel drive. So correct me if that is not the case. Are these a good solution? Basically, a good solution, it's hard to determine. Basically, your customer will have to choose what is the most convenient platform for him. So it will be either a rear-wheel drive, either a front-wheel drive. And basically, you will do the setting once, but then normally you won't change. This type of platforms, you need to make a few considerations. First of all, can you reposition the center of gravity? Center of gravity repositioning or positioning is extremely important to ensure that you have sufficient stability. You also need to load a new drive program in this wheelchair, because otherwise it will look like a front wheel drive, for example, but it will drive like a rear wheel drive. That's not what you want to have. Very likely you need to adjust the seating program, because when you have, for example, power leg rests, you don't want to have the angle of the leg rest compromising the caster clearance. The suspension system will also be not ideal, I think. You have to build it to be to be used in a front wheel platform and a rear wheel platform, but you will never be able to achieve the best positioning of your suspension system. So in my opinion, it can be a solution, but be aware that this will be always a sort of a subpar solution. It won't be offering the best driving experience to your customer. So let's go over to the next question. Is ESP or gyro needed on mid-wheel drive? That's actually a very good question. I would say it really depends on the drive control that you're using. Normally, if you're using a standard joystick, so the joystick that comes with the wheelchair, I would say that a gyro or ESP module isn't mandatory. It won't help you really with the tracking, because at high speeds, the mid-wheel driven platform is already a very stable platform. But if you change your drive control, for example, a drive control with buttons, then it can be really helpful. So it's not only to help you, an ESP module is not only to help you with the tracking at high speeds, it actually helps you also with the tracking at low speeds if you have the drive wheels on different surfaces. For example, if you have one drive wheel on grass and one on the pavement. Normally, without an ESP, you should also have to compensate them. If you have an ESP, once you provide the command to the wheelchair to drive straight, the ESP will help you then also to compensate with the motors to have a straight line. So I hope that covers that question. So ESP can be used on a mid-wheel drive, but I would say it depends on the drive control. I currently have answered the 2 questions that came in. So if you have more questions, please send them via the chat. I can keep it open for, let's say, another half a minute to a minute. But if I don't see other slides or questions coming in, we can wrap up the webinar. And then I hope also to see you the next time. So I can't see any other questions coming in right now. Let's wait a few more moments and then we will see. Okay, no more questions are coming in. So I really like to thank you to join our session for August. I really hope to see you back for the session in September, planned for September 22nd. But as I already mentioned, together with the handout and the link to the recorded version, you will receive tomorrow the invitation for the upcoming webinar in September. I wish you a very good remainder of the day and hope to see you back in one of our next sessions.